Hey everyone, welcome back. Today we are going to solve another LeetCode problem, which is valid parentheses using Python. Where okay, so let's discuss what is the problem statement. Imagine you are given a string that consists only of parentheses. These parentheses can be round parentheses, these can be curly parentheses or round parentheses. We have to determine if the arrangement of these parentheses is valid. In simpler terms, we are checking if every opening parenthesis has a corresponding closing parenthesis and if they are correctly nested. What will be our approach? Now let's discuss our approach. To solve this problem in Python, we will utilize a stack, a fundamental data structure that operates on the principle of last in first out LIFO principle. Here is our plan. As we traverse through the string, every time we encounter an opening parenthesis, we will push it into the stack. When we encounter a closing parenthesis, we will check if it matches the most recent opening parenthesis on the stack. If it does, great, we will continue. If not, or if we run into a closing parenthesis with an empty stack, the string is invalid. So that's it for the explanation. Now let's go to whiteboard and see how we can implement or what is the behind the scene of the principle we will be working on. After discussing and explaining on whiteboard, we will come back on the code section to write some code to implement the logic and solve this problem. Okay, here I am. We will take a stack to store the values or the opening parenthesis, and we have a map. In the map, we will store the opening bracket as a key and the closing bracket as a value of that key, and similarly for all three brackets. Okay, let's consider an example. If we have a input string as this, first we will iterate on the string. Okay, next we will store the current value of the string at the current index. That will be for suppose it is at 0 index, it is as 1 index, it is at 2 index, and it is as 3 index. First the for loop will give us the 0 index, so we will store the current index of a string in a variable. We will name that variable, for example, char. So we will store that variable in a char variable. Okay, so basically this means that we have stored this parenthesis, opening parenthesis in a character variable. Next we will check if character is at the as a key in the map. You can see it exists as a key. So what we will do is we will push this into the stack and it would look like this. Okay, next we will check in the next iteration. We will have this one. Now we will check in character variable we will have s of I, which is 1 at this time, so that will be our this one. So in character, now we have this closing bracket. Next we will pop the last value from the stack and we will store in a variable such as named or you can say top variable. Okay, so it will basically contains the value that is that we have pushed onto the stack recently, and it will take that value and we will store that value in a top variable. It will help in further looking up in the maps or while removing the elements from the stack. Okay, so first we will get this value by a method remove element in Dart, or in Python there is pop method. In TypeScript there is also a pop method, so that is also done. Next we will check if the top variable or the top value, which in this case is this opening parenthesis, opening round parenthesis. Now we will check if it exists in a map as a value. So you can see it exists in a map as a value and we will get that value. As I have said that in the current iteration, the character has this closing bracket, and now we have also this value. We will compare if they are not equal. It means that the string is a valid, because you can see that we have a opening bracket also and a closing bracket also, so that completes a parenthesis, so it is a valid string. Okay, so if they do not matches, that is a valid parenthesis. If it matches, we will have a condition something like this, not equal to. So in this case, if this condition is true, the string is not a valid is not valid. If this condition goes wrong or gives false, it means that we have the string that is valid. It is a bit difficult in explanation as I am also confused. So let's back, but I have tried my best to explain the code or the approach to you. By jumping back into the code, we will see how we can solve this by writing some code. Okay, so we are back in the code section. We are given with a definition named as invalid. It receives two arguments, self and string. Our concern is with only this string. This function returns a Boolean variable which will be displaying that indicating that the given string is a valid or invalid. Next, we will declare a stack as I have discussed in the explanation. For that, we initialize an empty stack named stack to serve it as a stack. We will store opening parentheses as we encounter them. For that, I will write stack and I will initialize it with an empty list. Okay. Next, we will initialize a map or a dictionary in Python that maps opening parentheses to their corresponding closing parentheses. This mapping is crucial for us to check if a closing parenthesis matches the last opening parenthesis on the stack. Let's try to declare our dictionary. We will name as bracket map. Okay. Next, we will initialize it with. Here, I will store the opening round bracket as a key and closing round bracket as a value, and similarly for remaining brackets. Opening round bracket as a key and closing round bracket as a value. And we will do same for the rest of these. Opening curly bracket as a key and opening closing curly bracket as a key. Opening square bracket as a key and opening curly square bracket as a value. Okay, so this is also done. Next, we will declare a for loop that would iterate through the each character in the input string which we are receiving as an argument, in this case s. Okay, so let's try to declare a for in loop for char in s. This for loop will return a single character every time it iterates through the string list string. Okay, so here we will check if the current character char is an opening parenthesis by verifying it if it exists as a key in the bracket map which we have declared over here. This is the bracket map. If it is, we will push it into the stack. If, sorry, in Python we do not use brackets. If char in bracket map, if it is present in bracket map, we will push it into the stack. So pushing, we will use append, the method that Dart provides us. If you're confused that we are talking about a stack and we are using the methods of a list, and here we also have used a list. Basically, these are the data structures that we can modify according to our needs. We can use a stack list as a stack. We can use a queue as a stack. It's our priority how we can handle the data structure and how we can handle the program according to our needs. So the methods would be, of course, off list, but we are using it as a stack. Okay. So next, in the else condition, if the current character is not an opening parenthesis, we enter in the else block, indicating it is a closing parenthesis or another character. For that, we will declare a else block here. First, we will check in the else block. If the stack is empty, when encountering a closing parenthesis if it means that there is no corresponding opening parenthesis. Hence, we immediately return false and we will exit the function. If not stack, return false. I hope this is clear. Now, after checking this, we will compare. We will retrieve the last opening parenthesis from the stack using the pop method, and we will store it in a variable. Let's name it as top. Top is equal to stack dot pop. In Python, the pop method basically removes the last element that we have pushed into the stack or we have pushed into the list. It will pop that element, means it will remove that element and will return that element, and we will store the return element in the top. This will help in the further lookup in the map. Okay. So next we will check, or we will compare the current closing parenthesis, which is char, with its corresponding opening parenthesis stored in top. If they don't match, the strings are invalid and we will return false. If bracket underscore map, and here we will pass top, is not equal to char. This basically means that this will go in the bracket map, this will look in the bracket map, and this part will look up in the bracket map the value of top, which in this case would be this, or it could be any other. So if the key is present in the bracket map, then it will return the value of that key, and we will check after retrieving the value is not equal to char. If it is not equal to char, we will simply return false and we will exit from the function. This means that the string is valid. The parenthesis dot match, return false. Okay, so that is also done. At the last, after iterating through the entire string, if there are any remaining opening parentheses left in the stack, it indicates unmatched parentheses, so we return false. If the stack is empty, it means all parentheses were matched correctly and we can return true. So after the for loop finishes, we will return not stack. I hope that the code is clear to you, and so was the explanation. So let's try to run this code. Okay, so our cases are accepted. Case 1 is accepted, case 2 is also accepted, and case 3 is accepted. So we can finally submit the code. To summarize, we have implemented an algorithm in Python to solve the valid parenthesis problem step by step. We have initialized a stack data structure and a mapping of opening to closing parentheses to validate the string. Each line code plays a crucial role in ensuring the correctness of the solution. And that concludes our detailed explanation of the Python code for explaining the valid parenthesis problem. If you found this breakdown helpful, don't forget to like and subscribe to our channel for more programming content. Thank you for watching, and we will catch you in the next video.